Hey everyone, this video is really just taking the form of an example problem. What's going to happen is on the next slide, you're going to see a graph, a motion graph, and there's going to be several different questions. Very simple, you should just hit pause, try answering the questions, and then as needed, watch the video to listen to me go over the answers. So here's our graph. It's a velocity versus time graph, velocity on the y-axis, time on the x-axis. I have 6 questions for you. Right now is the time when you hit pause and just try each problem. Okay, we're going to go through this one by one. I just kind of hid the second and third just to give myself a little more room in terms of me working it. But let's look at it. The first one is saying, when is the velocity negative? So this is obviously some object. It's moving. It's asking, when does this object have a negative velocity? All right, it's a velocity graph. That's what's on the y-axis. So in this case, when the velocity is negative, it's just really going to be when the graph has a y value that's negative. When is that taking place? Well, right when you get to here, which is just about 3. I recognize it's maybe a tad more than 3. All the way until right here, to a little more than 12. So for the first one, it's kind of between t equals 3 to just a little over 12. We're not going to worry in this class about like bound or unbound inclusive data points. Get the general idea. It starts going negative right after 3 seconds and it stays negative until just after 12 seconds. That's all I care about. Nice. B, what is the object's displacement between 0 and 3 seconds? This one might be a little tricky. This is a velocity graph. All right. I have units of meters per second on the y-axis and units of seconds on the x-axis. It's the area under the curve. That area will give me the object's displacement. That's how the units work out. So I know how to find the area under the curve. This is a triangle, so that's going to be 1/2 base times height. So that's 1/2. The base is 1, 2, 3. 3 units, 3 seconds. And the height is 1, 2, 3. Oh, that's easy. Well, 3 times 3 is 9. Half of 9 is 4.5. The unit for displacement is in meters. So over this time, had a displacement of 4.5 meters. C is asking, what is the object's acceleration? I'm going to switch to blue. What is the object's acceleration at 4 seconds? Right here. What is the object's acceleration? Okay. From 0 to 5 seconds, look at this line. It's a constant negative sloped line. Well, since this is a velocity line, velocity graph, it's the slope that's going to tell us the object's acceleration. Whatever the slope is all on this line, the slope is constant. Therefore, anywhere on this line between 0 and 5 seconds, the acceleration is constant. So the slope, well, that's delta y over delta x, change in y-axis over change in x-axis. Let's see, it looks like we go down by 3. I'm just finding the slope of this line. I go down by 3 when I have a run of 1, 2, 3 of 3 there. Okay, negative because I was going down. The line is down and to the right. That's easy. -1. The units, meters per second squared. That's the acceleration. Moving on, D, E, and F. Okay, here we go. D is asking, when is the object speeding up? Careful, this was on the summer assignment. Okay, speeding up is when the velocity is either getting more and more positive, going faster and faster in the positive direction, or when it's getting more and more negative, something going faster and faster in the negative direction. Negative acceleration does not necessarily mean slowing down. Remember, negative just means like left. You can absolutely get faster and faster and faster to the left, just like something could slow down to the left. Okay, so to start off with D, some obvious places that I would expect you to recognize, since this is a velocity graph, right at this spot, the object has a 0 velocity. And then it's going faster and faster and faster. Velocity is increasing. So absolutely for part D, between, what is this? We have 11, 12. Between 12 seconds and just shy of 11, 12, 13 seconds, it's speeding up. It's also speeding up between these 2 points, just because the velocity is increasing. I'm going from a velocity of 2 to a velocity of 4. So also between 15 seconds and 19 seconds. The one that people often miss. Okay, there's another spot. And that other spot is here. Here the object has a 0 velocity, then it has a negative 0.5 velocity, then a negative 1 velocity, negative 1.5, negative 2. Here the object is going faster and faster in the negative direction. So also between the time of 3 seconds to, what does that say, 5 seconds. All 3 of those times the object is speeding up. Here it's speeding up in the negative direction. Here it's speeding up in the positive direction. Last one. Or I'm sorry, not next one. E. If the object started at x equals 0, when does it return to its starting point? Okay. Well, again, a displacement is based on the area under the curve. I'm switching to green for this one. Here's the start. In the beginning, it has a positive displacement. This is a positive displacement. Okay. To get back to x equals 0, I would be looking for when it has the same amount of negative displacement. Just by eyeballing it, the same amount of negative displacement is, I don't know, maybe right around there. Positive, negative cancels out to around 0. We could do this a little more mathematically. We saw from before that from 0 to 3 seconds, delta x was equal to 4.5. All right, we found that before. The area under this curve here is 4.5. The area under this little triangle, that's going to be 1/2 base times height. That's 1/2 2 times negative 2. 2 times negative 2 is negative 4. Divide that by 2, that's negative 2. So this little triangle right here, all by itself, has a displacement of, I should have a negative 2 meters. I need to cancel out 4.5 meters though. So I have 2 gone. I need to remove 2.5 more meters. I need negative 2.5 meters in this section. I'm going to switch over to red. So I need 2.5 meters around here. Luckily, this is just a rectangle. So I have base times height. All right. The base is, I'm not really sure, that time. The height is always negative 2, and that has to equal negative 2.5. Solve for B. B is equal to 1.25. So 1.25 seconds later. Okay, so here's 1 second. Here's 0.25 more seconds. If you do the math, that adds up to be at 6.25 seconds. Okay, tough one to do mathematically. Okay, bare minimum, hopefully you recognize that it would happen right around here where you have canceling displacements. Okay, lastly, part F, at the end of its journey, does the object have a positive or negative displacement? Again, displacement is area under the curve. If it has more positive area, more positive displacement, it would be positive. If it has more negative displacement or more negative area, it would be a negative displacement. Just by looking at it, just by eyeballing, I can tell that this whole section here and this section here is going to be more positive than this section. You could prove it mathematically, and if you did that, awesome. Okay, just running short on time. It's going to be more positive just because there's more positive area than there was negative area. Okay, that's it for the video.